Yo guys, what's up? Welcome back to the series. So, in this part of the series, what we're gonna be doing, if you guys remember, we left off with creating graphics. Well, we left off by making a button that beeps, but we want that button to actually open up an instance of our console, which is like the thing that we were able to write commands in. So if you don't know what I mean by console, it's like the thing that except that we were able to write like all these commands in to, like this. It's like this except in our operating system. And we actually want to open that on our GUI, and that's kind of what we're going to be doing in the upcoming parts of the series. Like, we're going to be working on that today. So what we're going to do actually is instead of just drawing the console window on the screen, what we're going to be doing is making an entire new class, and in this class you'll be able to create any kind of tab you want, including the console one. And they're gonna have properties and a whole bunch of attributes, so you can make any kind of tab you want, including the console window tab that we're gonna be making. So anyway, we'll just start by creating the class, just by right clicking on your graphics folder and adding a new class, and just call it tab, because that's what we're gonna call our windows. Really, we're just gonna call them tabs, because we don't really have much of a window system set up yet. We're just gonna call them tabs because we're going for something simple, at least for now. And just to be clear, for example, you see how I'm moving around Notepad right now? That's gonna be the same thing, except instead of called like a Notepad window, it's called a tab on an operating system, and that's what I mean. So this would be a tab. And the first thing you gotta think of is what are some attributes to a tab. So obviously it's got its X and Y value. So what we're gonna do, I'm actually gonna do something special for the X and Y values, and so create the public int X. And the reason that I'm putting in these squiggly brackets is because I'm gonna add in two attributes called get and set, and the difference is it's gonna be a private set, and what that means is that you can only set this inside of this class if you're inside of this class, but you can get it outside of any class. So yeah, only the tab can modify its X and Y value directly anyway. We'll do the same thing for Y. And now what we're gonna do is go ahead and create some constant values. I'll actually make them up here. And these constant values, we're gonna make it accessible for anywhere inside of our little operating system here by making it internal. And we're gonna make a constant, and that basically just means it can't change. Make some integers, and the constant values we're going to make are the default window size. The windows are going to be squares, so we only need one for that. The top part of the window, and by the top part of the window, I mean this bit right here that you drag. That's going to be the size. It's going to be 25 high. And then the X button size, and the X button is just like the close button. And then also, we'll define some colors. So the outline of all our tabs are going to be white. And we need to do some imports here. System.drawing. The same things we imported in other things when we were modifying graphics for the same reasons. And then we'll also make the X button red. So we'll make a pen for that as well. And another thing we're gonna have to do is store every single tab, and we're gonna make it static so that it doesn't have to be in a tab class. And we're gonna store every single tab in a little list called tabs. In this list right here, we're gonna store every single tab, and this is accessible only from inside this class. So whenever we create a tab, we're going to add it to this list, and whenever we close one out, we're going to have to remove it from that list. And the reason we're going to do that is so that we can loop through every single tab and check if someone clicked a tab or something, and it's just going to be really useful for us and handy. Another thing that we're going to need to add is we're going to create, this is a little bit of a special, a weird modifier that you might not see everywhere, but it's called private protected. And basically it means that in any instance of a tab, so even if you have a class that's like this, you'll be able to access it. Here, you'll be able to access it in this class, as long as it's inheriting it. And we'll make a boolean being dragged. So that's just simply, if the tab is being dragged, we'll be able to know. And we're gonna need that just for a little bit. We're gonna need it in the future, not right now, but later in this video. And then also, since we're gonna be able to drag tabs, you're also gonna want to know the offset. So what I mean by that is, when I drag this tab from point A to point B, as you can see that my mouse remains on the same part of the tab that it did when I was at point A. I'll help to explain this better in MS Paint. So let's say I have a tab right here, and consider the red my mouse. So I click here, and let's say I drag the tab to right here. Now, if you don't include offsets in your math equations, what's gonna happen is the tab is gonna appear right here. And I'm just gonna make this a bit bigger so it's easier to understand, because they were overlapping there. So yeah, again, let's say that your cursor is the red dot, and you click right here, and then you drag the tab, you drag your cursor, and then you click right here, and then that's where you drag the tab to. Now, if you just set the tab to the X and Y position of this cursor right here, then what it's going to do is it's going to move it to that. So the corner of the tab is at where you put the mouse. But that's not what you want. You want the tab to get dropped off like that, because as you can see, you didn't click the tab up here, you actually clicked it down here. So the way we do that is we calculate the X and Y difference from where you clicked here to the X and Y of the top left of your tab. And then whenever you drop off the tab, it gets subtracted, and then the tab moves up by whatever this difference is. And I know that's kind of like a little bit hard to explain if you didn't really catch on immediately, but I'll explain it after we write the code. But just to know that the reason we're doing that is for that. You don't have to understand it yet, but like the reason that we're making these variables is for that. You can call them like offset or something. And then also in your tab, you're gonna have components. So for example, if you look at this window I have open right here with Visual Studio, there's a bunch of buttons. Like I'm clicking on some buttons right here. They're all components to your tab. And you're gonna want to store all these components. So what we're gonna do is make a new class in our graphics folder again. Right click it, add new item, tab component. And you could consider tab component as a control. If anyone's ever programmed in system.windows.forms, you could consider your tab component as a control, and you could consider your tab as a form. If that helps better understand, if that helps you understand it better. There are going to be a bunch of differences, but like just for the grand scheme of things, they're basically the same thing, except one's in our operating system and one's in Windows. And for your tab component, you're gonna want the same things, your X, your Y. So I'll just copy and paste those. But you're also gonna want other things in your tab. And one thing would be the size. We'll just make it a byte. I'll make it read only so you can't change it for now anyway. And then that's basically it, but we're obviously going to want to make a constructor so we can just input these values whenever we make a tab component or control, whatever helps, whatever whatever helps you understand the best. It's either a control or a tab component, basically the same thing. So we're just giving the user an option to input all of these variables in the constructor, and we'll just set them. And the final thing we're going to want to do is we're going to actually want to know what we want to draw on the tab because of this tab component. So right now all we have is the X, the Y, the size. We don't know what it actually wants to draw on the tab. So for instance, like if you look at this button right here, what it does, say that this list item right here is a tab component. It draws on this arrow, this picture, and this label. And the way that we're going to know that it draws that on is by giving the user an option to say what they want to draw. And we're going to give it the option to put in, we're going to give them an argument to pass in called the tab sender. And the reason that we need to pass that in is because you're going to want to know where the tab is located so you can draw it in its appropriate locate. You can draw your component in its appropriate location instead of just somewhere random on the screen. You're going to have to make sure it's aligned with the tab. So you got to know where the tab is by including it there. And one thing that this may look kind of familiar to is if you've ever programmed in WinForms. I'll actually open it up really quick. I have a WinForms application. If you are familiar with events on WinForms, one of them is called Paint. If I double click it, you'll see that it has a sender as well, object sender. And it says object, but it's literally a form. It's always a form. And as I said, tabs are kind of like forms. So as you see, it has tab sender, form sender. And I just need to fix it really. Okay, never mind. I'm not really gonna worry about that right now. But as you'll notice, this is really similar to an event in when forms. The only difference is that it has no argument, and that's because this is really simple right now. We don't need draw arguments like maybe like that. Like we don't need that yet. All we really care about is the basics. So all we need to know is this tab that sent it. The tab that has this component. That's what that is. And we're done with this actually. Now we're able to go back to tab, and now what we can do because of that is we could create a list. And it's just going to contain every single component on the tab. And for now, there are a few other things we can add, or like really, yeah, there are a few other things we can add, but like for now, let's just leave it at this. And I know that I am saying that this is like the basics or it's simple, and I am like, I might be saying that, but it might not actually seem that simple. Basically, when you're doing graphics in operating system programming, it's really complex, so you just have to kind of bear with me, and hopefully you'll understand as I write more and it all comes together. Because if you don't understand this, all I'm doing right now is preparing. We actually haven't done anything significant yet. We've just prepared to do things significant. So don't feel too bad if I'm kind of all over the place right now. It should all come together shortly. But anyway, again, just like we did with the tab component, we're going to want to create a constructor so that we can initialize everything, pass in these variables. And when we make a tab, we're going to want to know where to put it on the screen. So int32, and I could write x right here, but I'm going to put underscore x because we're going to want to modify those variables in the constructor. So we don't want to like use up x and y, because we want to make our own variables called x and y, just like this. And we're just going to set them to this. And the only reason we've done this, instead of just using these variables, as I said, is because we want to change them. And there are a few, and one of the reasons we might want to change them is because we want to make sure it's not out of bounds. And when we do that, we've done the exact same thing with our mouse before. Right here, as you see, we checked if it wasn't out of bounds. If it was out of bounds. And we're doing the same thing for the tab right here. The only thing we have to do that's why it wasn't coming up. So before we do that, what we're gonna have to do is go on to here, back to our GUI, and just make this public. And now this should work, right? Yeah. So now what we're gonna do, the reason we made this public is so that now we can access the canvas outside of the GUI, and the only thing we really have to do is make sure that we don't modify it that much. All we gotta do is be like somewhat responsible and just only use it to check like the size of the screen and whatnot. And the only difference here, from how we checked if the mouse was out of bounds, is that we gotta check. Instead of the size being 2, which was the mouse size, what we're gonna do is check if it's the default window size, which is the integer we put up there. And I'm gonna kind of go. It's also it's gonna be a little bit different, but all we're doing is checking if it's out of bounds. And math isn't really my strong suit, so I can't explain this thoroughly. But if you just look at this, like mathematically, and fill in everything, all you gotta know is this right here is the columns of the screen. And it says columns, and as I said earlier, the columns and rows are just your X and Y of your screen. They're the width and the height. So if you just take that into consideration, this is just the width or height of your screen, and this is 400, which is the size of your tab. It becomes nothing more than a simple math equation, and it becomes a lot more easier to understand. So I'm gonna just write it out first. And we're doing the exact same thing in this next check here. Now the only difference is, instead of just subtracting the default window size, at the bottom of your screen there's a tab bar that we made earlier, and it's got a size of 100. So we're gonna have to account for that. Just throw in the extra 100 from the bottom of the screen. And another difference, actually, now that I think about it, is that we only have to check the bottom right. So, because, you know, you can't drag the tab to the top left because your mouse doesn't go there. And let me just finish this statement here. True. You'll now notice that this right here, although it looks really somewhat complicated, it's the exact same thing as this second half of us checking if our mouse is going out of bounds. We just don't have to check the first half because it can't. It's impossible for your form to go out the top left of your screen. The only way it can is if it goes out the top right, or the bottom right, and that's because it has a size of 400, so it could go outside the bottom right. And if it does go outside the bottom right, all we're going to do is modify our X and Y so that it doesn't go outside the bottom right. And what we'll do is just make it go to the furthest possible point to the right of the screen without it actually going off. And the reason I'm running +1 here is because I don't want it to go 1 pixel out of bounds, so we'll just make sure it doesn't do that by +1. And I'm doing the same thing for the y-axis, but again, we have to account for the tab bar that has a size of 100, and then also the 1 pixel to make sure it doesn't go 1 pixel out of bounds. So add in the extra 1 there. Or I'll just make that clear. Now we have to, now that we figured out the X and Y situation, make sure it doesn't go out of bounds, but still give the user the opportunity to input the X and Y of the tab. What we have to do is actually set the variables that we made up here. So it shouldn't be too hard. Make the component list we made. We're not actually setting the components yet, we're just initializing a list, so it's not going to cause us problems later for being null. And then set the X to the X-axis that we just made. And then set the Y to the Y-axis we just made. And then obviously tab isn't being dragged right now, so we'll set that to false so it's not null. And the next thing we'll do is actually add the tab to the list of tabs. So what we're doing is we're accessing this list we made up here that contains every single tab, and we're adding ourselves to it, because in this constructor what we're doing is making the tab. So we're adding ourselves to the tab list. Since now we're in a new tab, we have to keep track of that. But just like the tab component, we actually have to draw the tab. So what I'm going to do is create a new private void draw and go back up here, and we'll just draw the tab right there. Draw it in the constructor immediately. And a few things that we're going to do is create some rectangles. So what we're going to do is create the top bit of the tab, and as I said earlier, the top bit of the tab is just going to be this right here. Access the canvas, because as you know, the canvas is what gives you access to do things like draw a rectangle, and that's how you actually directly draw on the screen. And for the pen, as you guys remember probably, we made an outline pen up here. It's just gonna, all this means is that we're gonna make our tab white. All this means right here is we're gonna make our tab white. It's nothing complex. And then we're gonna give it the X and Y value of our tab that we set right here. We're gonna give it the X and Y value that we set. And now we gotta give it the width and the height. And as you guys remember, we made a default window size of 400, and it's gonna be a square. So yeah, all we're doing here is making a rectangle that's white. It's the X and Y value of the tab. The width is the whole tab, and now the only thing that's incorrect here is that we don't actually want it to be 400 by 400, since we're only drawing the top bit. And if you remember, we made a different constant called window.topPartSize, and that's 25. So all we're doing here, all this means is this right here means drawing a rectangle. That's what that means. It's gonna be kind of hard to write, so I'll just explain it. This part right here just means we're drawing a rectangle onto our screen. This right here just means that we're making it white. These variables mean that we're making it the X and Y of our tab. This right here just means that it has a width of 400, which is the width of our tab. And this right here means the rectangle's height is 25, and 25 is the size of the top bit of the tab. And I don't really have to explain that again. I already did 3 times. It's just this up here. The next thing we'll do, we'll create the X button, and the X button is just this, so that you could close it. Again, I'm just gonna make the outline of it white because I want it to be outlined in white, but I'm gonna make the inner bit red, so don't worry about that. Now here's where things get a little bit tricky math-wise. We have to take the default size of our window and subtract the top part size of the window. And remember, this is also a square. It's not just the height, it's also the width, because we're making the X button a square, not a rectangle. So that's why we're subtracting it, because it's going to be 25 by 25. And what this is doing, this is getting the left part of your tab, which would be right here. It's adding in the size, which would now take you to this side here, which now means we're here. But now we're subtracting. Oh, I put in the wrong thing here. Did I make a size for the X button? Yeah. Minus tab dot X button size. And then, so now once we're here at the rightmost part of the window, we're subtracting the X button size. So that means we're going to go to right here, the leftmost part of the X button. And that's just getting the X of the X button. And now we do the same thing for Y. We get the top part of our tab. and then now all we have to do is, so now what we've done is we got the x-axis and then we got the y-axis, which now takes us to right here where my mouse is, if you can kind of see that. Maybe I explain this better on MS Paint. So say this is our window. What we've done, I'll finish it first and then I'll explain it. Then what we're going to do is just put in the size of the X button. So essentially, what we're doing right here is getting the X part of our window, which would be right like that. And then we're adding in the size, which takes us to right here, and then we're subtracting the X button size, which will now take us to right here, roughly. And then we're selecting the Y-axis of the tab, right here. So what we've now done is we've made this coordinate. We have selected this coordinate. But now we have to now what we did is set the size of the tab to the size of the button to 25 by 25. So we've just made a rectangle that starts from there and is 25 by 25. And that right there is going to be where the X button is. Except the only thing is we only did the outline. Now, we're going to actually have to fill it in. So it's the same logic, except we're going to fill it in, and that just means we're going to do draw fill rectangle. And this time we're going to make it red using the X button pen. So technically this right here is white, but if I were to set it to white, you wouldn't see it because the background is white. And then the same logic applies, except we don't want it to actually overwrite the outline, so we have to decrease it by 1 so that the outline remains. Same thing for Y, increase it by 1 so that the outline stays there, and same thing for the size, we had to decrease it by 1 so that outline remains. So now what we've done, same thing, except we filled it in. That is simple. The next thing we're going to do is create the actual window outline. And I already did it here, but I like the tab outline. And to do that, all we're gonna do, it's just simple because all we're doing is we already have all the variables. We're gonna draw the rectangle just like we did before. Use the outline pen because you want to make it white. Select the X, select the Y. Now, if you remember, I'm going to just delete all this because we didn't actually make it yet. All we've made so far is the top part of the tab and then the X button. But now we actually have to make this. So how we make that, we can set the X to this because the X is the same. So we don't have to change the X. But as you'll notice, it's a little bit lower than the tab, than the top bit of the tab. So all we do is we make it a little lower by the top bit of the tab, because we made a variable that contains the top bit of the tab. And then now all we could do, set the window size, but the height is actually also going to be reduced by the top part of the tab because it's already accounted for up here. So all we have to do is reduce the size by the top part because we've already made the top part, so we don't have to. So we had to subtract 25 or the top part because we've already drawn it. We don't have to make it bigger. than it already is. And now we've actually just drawn the whole window now. But what we actually have to do is say there's something in the window. As you remember, we made a list that contains all the components. And let's say like this text is a component. We have to draw it. When we do that, loop through every single component. Component, tab component, TC, and this are components. So we're going through every single one of our components and then just draw it. As you guys remember, we made a draw function right here. It does nothing right now because we haven't made any components that actually draw stuff now. But when we do, we'll be able to draw them. And as you remember, we added the argument tab sender. And the way that we pass that argument is all we do is write this. Because we are sending it. So we write this because we're sending it from here. So we put this because that's how we select, well, this. We're done with that. Now, whenever we add a component, it's not going to be drawn immediately. It's going to have to wait for this function to be called. If we were to just add it to the list directly. So, the way that we fix that, public void add component, and then the component that you want to add, and then all you want to do is add it to the list of components to keep track of all the components, and then actually draw it on the screen. Same reason that we put this, because we're the people sending it, so we write this to say that we're sending it. Another thing we're gonna have to do is move the tab. So if we want to move the tab, we're obviously going to want to know where, so we select the new X, the new Y. All we want to do is update the variables in our tab accordingly, and then we just draw it. We just draw our tab. We just redraw it at its new coordinates. It's that simple. And then we'll make a void close to close the tab. All we're gonna do this dot tab or tab dot tabs dot remove this. So we're just removing ourselves from the list of tabs, so it won't ever get drawn again. But what you might notice is that we don't call these functions anywhere, and you might be wondering, where are we going to call these functions from? So this is where things get a little bit tricky. What we're going to do is create some public static voids, and just like the tab bar, try process tab bar click, try process tab left mouse button down. So whenever the user clicks down on their left mouse button, this is going to get called. And we're going to ask for the mouse X and mouse Y. We're also going to do the same thing for release. Whenever they release it. And the reason that we need it is because when you click down on a tab and drag it, you want it to release. Whenever you release your mouse button, that's where the tab ends up at. So that's why we need to distinguish between the two. And in left mouse button down, in both of these actually, what we'll do is say if there are no tabs open, don't do anything. And the way we do that, if tab.tabs count is 0, so if there are no tabs, don't do anything. Pretty simple. That just saves a little bit of lag, because you might notice when we actually run this that there's gonna be a little bit of lag, but what we're gonna do now is say for every tab t, or like tab, whatever you want to call it, in tab.tabs. So for every tab that's open is basically what this is saying, and we're gonna get every single one of them. What we're gonna do is, first of all, create a rectangle at where the mouse is at. And just give it a size of 1 and 1. And this may look a little bit familiar. That's because I did it right here. And that's just the only reason we're making it in here, or in here, is for the same reason. It has a really handy function called intersects with, and all that does is lets me know if the mouse is on top of a button, or like anything really. So if the mouse intersects with, or is on top of, and we're gonna have to make a new rectangle. What we're gonna do, this rectangle is gonna be the top part of the tab. So we're gonna check if the mouse, or not that, if it's on this bit of the tab. This bit right here. Because if it is, that means that the user is trying to drag the tab. So we'll get the tabs X, the tabs Y. And then the width is gonna be the default window size, except if I do that, that means that it's gonna go from here to here, which would create a problem, because if the user clicks here, it's gonna think that it's dragging it. So what we want it to actually do is go from here to here. And the way we do that is we subtract the size of this button. And for the height, we just want to get the height of this, and we have a handy constant variable that will get us that. And now, if it does intersect with it, what we're gonna do first is see where the mouse clicked relative to the tab. So I already explained this. I don't know if I can explain it better a second time, but I'll try. What we're doing, say that you click right here, and say that, and considering that this right here is the 0, 0 of the tab, what we want to do, this right here would be like 7, 3, and we just want to get that. We just want to get where the user has clicked relative to the top left of the tab. Oh shoot, I'm typing the wrong thing. Tab.dragDiff_x. And yeah, it's these two variables that I tried to explain my best earlier. And if you don't understand what I said, later when we're testing this, keep this in mind. If you don't understand what I said, get rid of these two lines that I'm about to make, and then you'll see the difference. So whenever we're actually testing this, go ahead and comment out these two lines, and then try to drag the tab and see what happens, and then you'll probably better understand why we have that there. or like don't do that actually. Set them to 0. Do that, and then you'll better understand why we have it like that. If you don't understand, it's like, I highly recommend it if you don't understand what I mean, because it'll help you understand the code better. And then obviously we're gonna want to tell the tab that's being dragged, because basically what the user's done is he's clicked onto this bit of the tab, so it means that he wants to drag it, or that they want to drag it, therefore it's being dragged. But obviously whenever you click down on the tab, there's one other thing that you can click, and that's the X button. So if the user doesn't want to drag, and if they want to, so if the user doesn't want to drag, that's why we're putting else. We're going to check if they want to, if their mouse is on the X button. And the way we do that, same thing, mouse location dot intersects with new rectangle, get the tab X, and this time what we're gonna do is get the rectangle of the X button. So we did do it once before, but I'll do it again right here. That actually plus. The Y remains the same because, you know, it's at the top. And then for the rectangle, we created some constant variables that will give us the size. And if the user does click there, then close the tab. So yeah, again, all we did, we got the X is right here. Then we got the Y is just right here. And then we got the size, which end result gets this entire rectangle. We did the exact same thing here. Now, later on, if we wanted to check if there are any elements, like a button, that the user is trying to click, we would check it here, but we're not doing anything that complex right now. But don't worry, like, that is not far out of our grasp. Like, we are almost able to do that. I just don't want to do it right now because it might be a little bit lacky if I do that, and soon you'll realize how important performance is on your operating system. I think we're done with this. But what we have to do now is actually process the release. So whenever the user releases their button, and this isn't nowhere near as complicated. Same thing, loop through every single tab. Now the only thing we have to check if it's being dragged, and the reason that we've got to check if it's being dragged is because, as I said, let's say the user clicks down here, it's gonna set the tab. When the user clicks down on here, being dragged is now true, and then the user is gonna drag their mouse, and whenever they release, it's gonna say this is gonna be called, and being dragged is still gonna be true. So whenever the user clicks down here, drags the tab over here, Whenever the user clicks down here, it's going to set being dragged to true. And then they drag their mouse on to wherever they want to drag their tab to. Being dragged is still going to be true. And then we're going to just go through every single tab and check if it's true. Because, you know, the user can release their mouse and not be dragging a tab, so we have to make sure it's being dragged. So since they're releasing, that means that they're done dragging. They release their mouse button. They're done dragging. As you see, they release their mouse button. They're done dragging. And now we actually want to move the tab. We made a handy function for that earlier. Again, I'm going to be using the, oh, whoops. I did a little bit of a typo right here. It's supposed to be mouse X. There is going to be the drag diff x variable I made, which might be a little bit complicated to some. So again, if you don't understand it, just set it to 0 up here, and then try to run your code with that 0 when we're testing it, and then you'll see what it does exactly. And that's done. We're already done. The only thing is, we haven't actually called these functions anywhere. So if you remember back in our GUI, this is where the GUI inputs get handled. So right here, this is how we checked if your left mouse button is down. So all we gotta do is add our whatever it's called, our process tab left mouse button down to it. This code gets called if your left mouse button is down. Is what I'll write. And we'll just go up here and try to process the tab left mouse button down. And just, as you guys remember, we need the mouse X and the mouse Y in order to do some required functions. So, pass those through. If you don't remember, mouse manager.x and mouse manager.y is how we get the mouse X and Y. Now say the user their left mouse button isn't down, that's why we're putting else. We're going to check if they're releasing it. So they've released it if their mouse button if their left mouse button is no longer being held down, because that means that they lifted their finger up and now it's no longer being held down, and the frame before that their mouse button was down. But now we'll just add in our, now we'll just add in the function we made earlier. Same thing, same variables that we're passing in. Now we actually want to open the tab, so we'll go to our tab bar, and if you remember in our last video we created a simple button that beeped. We actually want that to open a window, so we'll just do that here. This is where we're going to create the new tab. I'm just going to make it go to the top left of the screen by typing 00, and we'll go ahead and run that, and hopefully everything works. This was a pretty large amount of code to add, but we'll see what happens. This is going to take a while because as we add more and more code, more and more classes, more and more folders, everything, compiling is going to take even longer. So, but I mean, if we look at everything we've done, we've actually done quite a lot of work, especially considering that creating your own operating system is a pretty difficult task, some would say. Yeah, we've done a lot of work. I'd say maybe like 500 or so lines. Or more than that, actually. Now that I look at it, probably like no, not 1,000. Yeah, 500 is probably right. Or like 700 or something. Probably won't be needing this anymore. Alright, here we are. If you remember, we made this. This was the button that beeped. Let's see what happens. Okay, so yeah, here we are. It makes this. Let's just see if we can drag it now. And as you can see, it dragged it. But you might be a little bit surprised. Say, well, it's dragging it, but it's not making multiple windows, by the way. Like, if you try to drag one of the old ones, it's not gonna work. But, now it's getting really laggy as I do this more. Or, no, it's not, actually. That's just, in my head. But, as you can see, there is a slight problem, and that's that it's kind of drawing over itself. And the reason it's doing that is because, well, we didn't actually replace the pixels behind it. There is, and as I said, the window is still there. Like, if I try to drag this one, it does nothing. I found the window again, but if I try to drag a random one, it's not going to do anything. And there is a fix for this. There is a fix. I did write some code to fix this. It didn't take that long. But let me tell you, it does take a long time to actually run the code on your operating system. It is very slow. So fair warning, is very, very, very slow. But I guess we might as well get into it. But it is very slow. You'll see. What we're gonna do first is go to the top here of our tab class. And to those of you who are experienced, I have no idea if this is fully optimized, but I am gonna try to optimize this later. I tried really hard to optimize it, and I was able to, but it went from being 2 lines to like 50 to 100, and I'm obviously, like, this video has already gone on long enough, so let's just do this simple way to do it. First thing I'm gonna do is drag these down here, because like I don't really know why they're down there anyway. And the next thing I'm gonna do is, this is where we actually get into it. Under here, make a new list. You'll notice that call this list pixels behind tab. This is where we're going to store all of our pixels. And just before I start explaining that, now looking at my code, I noticed I made a mistake. It's not going to cause any errors now, but might later. So just change your components here from private to protected. And now for the pixels behind tab, this is going to be all the pixels behind the tab before you draw it. So it's just going to save them so it can replace them after you take your tab off of where it originally was. Now the way that we store these is using the tuples, and if you remember, we did the same thing for the mouse. We stored it in tuples, points and colors, and the reason we're doing that is because a pixel has a point and a color, so it's all we need to store it. Same reason. We're doing the exact same thing we did with the mouse, except on a much grander scale. And grander doesn't mean better in this case, it means slower, so just keep that in mind. And back in our constructor here, we're going to go up here and define the list. And you'll just be able to just press enter and it'll open up for you. And we can make this a tad quicker. If we go into our file into our command manager, you'll notice that we have a capacity, and I was saying how in large cases that might actually be a little bit better for your performance if you add a capacity, even though it's not required. Well, this is one of the situations where it will actually make a pretty big impact, because we have to add the window size is 400 by 400, so the capacity is going to be that. So let's just add in the capacity tab.default window size times tab.default window size. Nothing special here, it's just basic math. Our tab is a square, so the way you get an area, or the area of a square, is length times width. So that's all we're doing. Now we have to add two new functions. And those, I'll just add them at the bottom here. Private void restore pixels behind tab, and store pixels behind tab. Restore is really simple, so we'll just do it right now. All we have to do to restore the pixels behind tab is to go through every single pixel we saved and, well, draw it. Draw a point is how we draw pixels, same thing. And now we have to make a new pen here because we have to use the color of the pixel. So all we gotta do is select the second item in this tuple, which is the color. This would be the first item, this would be the second, same thing we did before. And the point is just the first item. And we're done, we're done. All we have to do, we don't even have to do anything, we're done. I'm just getting rid of that so that we can make it simply 2 lines. Now we actually have to store them, and it's a little bit harder, but it's not too hard, so we'll do it. The runtime of this was 7 seconds. Okay, runtime 7 seconds when I actually timed it. So first thing we're going to do is get rid of the old pixels that we stored before, if any, just by clearing the list. And now we're going to create 2 uints, and the reason I'm just making them uint 16 is because we don't need to. A uint 16 is the same thing as uint 32, except it only goes from 0 to 65535. And I want to save as much processing power and memory as I can for this, so I'm making them uint 16, because we don't need it to go above 65535. we actually only need to go for 400. Now we're gonna make an int fixed y and fixed x. Don't worry about this right now. I'll be setting them later. I'm just making them beforehand, so we don't have to do it later. Now here's where we loop through every single pixel that's behind the tab. So while the y is greater than or is less than or equal to tab.default window size x equals 0, and while x is less than or equal to tab.default window size, what we have to do now, oh shoot, I put in the wrong thing. What we have to do now is type in, is set the actual values for fixed x and fixed y. And what they are, we're getting the x of the tab, and then we're going to add in the relative x. So I'll explain what that means on Paint. I mentioned it once before, but I'll just explain. Say that this is your tab, alright, and say that this entire white space is your operating system. Although your window might be at 50x, 50y, the relative x, say right here, say that I select a point right here, the relative x and y of that point, I don't know if you can see it, but I drew a little point right there. The relative x and y relative to the window is going to be 1, 1 roughly for that point. But the reason that we're calling it fixed x is because we're taking the x of this and the y of this, and we're adding it to this. So now we have 51 and 51. And that's how we get the actual position of the pixel on the screen. So this right here is the position relative to the tab, but this right here is the position on the screen. And that's all we're doing there. And then we'll just, now that we have those the actual positions on the screen, we'll add it into our list. And the way we create a tuple, we did it before. Just type in the tuple data right, the type of the tuple right there. And then we put a bracket, and then we type in the information. So we have to create a new point for the first item. And obviously, we got the fixed x and fixed y. And now we have to get the color. So we just select our canvas, and then we can get the point color of any pixel on the screen. Get point just means get pixel whenever you see that. And yeah, that's it. Now we have to create x. And the one thing I didn't explain thoroughly is the loop. We're actually running really, like, our video has been going on for a really long time now, so I'm not going to explain that much, but basically what we're doing is we're going through every single y-axis on, say this is our form. We're looping through every single, say that each one of these is a pixel on the y-axis. I know it's just nowhere near, like, pixels are way smaller, but just for sake of explanation, say that each one of these little indents is a pixel. We're going through every single one of these in this while loop, and then we're getting every single pixel on the x-axis for every one of these. And basically all it's doing is it's getting all of the pixels behind the tab, every single one. It's looping through every single one. And now we're done. All we actually have to do is actually store the pixels, and we do that, or restore them. So what we're going to do is on our close, when we close the application, we actually want the pixels behind the tab to be restored. When we move it, we want to restore the pixels. And I believe that's it for now, but now we actually want to store them, and all we need to store them is whenever we draw. Let me just make sure. I'm just going to check my code right here. Yeah, that is what it is. So you do draw it right here. And I'm gonna run this. In the next video, we're creating custom file types, and we're gonna be able to draw text on the screen in whatever font that you make or you want. So it's pretty cool. I'm gonna be making it right after this video, so because I was just going crazy, like I couldn't stop programming because like I was having a really fun time making an operating system. So I ended up doing a lot of work. I was working for hours. What kind of? Oh, you can't see it on my screen, but right here it says IntelliCode suggestion. It's suggesting me to do this for some reason, and it got rid of the suggestion after I wrote that. That's kind of weird. And not only is this going to take time, but this takes time as well. So it's going to be like 15 seconds. But I will try my best to like, see if I can optimize it. I tried so hard, but like, I just gave up because I didn't know what was causing the lag. I might have to like create my own canvas class entirely. It's not frozen, it's just working for 7 seconds here. 3, 4, 5, 6, 7, and there you go. So it stored the pixels behind the tab. That's why it was taking so long. And that's it, restoring the pixels. And now it's gonna store them again. 1, 2, 3, 4, 5, 6, 7, and there you go. And you can add in another one. It's gonna take 7 seconds. 6, 5, 6, 7, there, and then you could do the same thing, just drag it down. And this one lets you drag it as well. The only thing is we're not gonna be dragging it a lot, so don't be like too upset that you can't drag it that much, because we're not gonna be dragging a lot. We're gonna be mostly working inside of it, and there's gonna be really no purpose to dragging it, at least for the next few videos. And hopefully by the time dragging it actually becomes something that you're required to do to have a functional, easy use operating system, hopefully by the time that happens, I'll have figured out how to speed this up. I had a bunch of ideas, and I was able to speed it up, but this went from being 2 lines to like 50, and this became a lot more complicated, so I'm not going to add it in this video. because of time reasons. And if you look at the timestamp right now, we're obviously running into a lot of time troubles. So yeah, I'm gonna call it here, guys. I'll see you guys in the next video. See ya.